stared at this one for quite some time, trying different things out until the solution came to me. It's going to potentially require some, some like just playing around with it to see what we find out. And the first thing I decided to do after looking at it for some time was to draw this in here. It's basically like RMS, but I've drawn it upside down. Um, so another triangle here, which will have an area of 920. But what we see actually is this is made up of four smaller triangles. And we can convince ourselves they're congruent because like this length must be the same as this. We can use parallel lines, I think, to show the angles are the same. We can use side angle side. They're definitely going to be congruent. And what that means is we can find the area of one of them. Actually, it's going to be 920 divided by 4. Okay, I'm just going to actually divide both by 2. 460 divided by 2, 230 is that red triangle. That red triangle seems to be quite strongly related to the shaded triangle that I'm interested in because they have the same height. So all I need to do is work out the ratio of their bases. And that ends up being not too bad, in fact, because let's say that the base of this one is just x. Then that would mean that this here is 2x. Um, but what else do we have then? So because we know we can split any regular hexagon into four equilateral triangles, to the very center point, that is also going to be 2x here, which means I'm basically done, believe it or not, because this here is going to be a half x, because it's just a half of the red triangle. And from here to here is 2x, so the base of the shaded triangle is 3 over 2x. So the red triangle and the shaded triangle have exactly the same height, but the shaded triangle has a base that's 1.5 times as big. And that means the area is going to be 1.5 times as big. And I'm there. It's going to be 230 times 3 over 2. I don't need to find the height in terms of x or anything. I just times by 3 over 2. Let's divide by 2 first. 115 times 3, giving me my answer of 345. Okay, I think the solutions do it slightly differently, but I think my solution is pretty good.